Okay, there was probably a lot of observations you could have made it while looking at Google Earth. Here are some that I had while I looked through Google Earth the first time. I noticed a few sections that really stood out to me as really big areas of either high elevation or low elevation. For example, this section down here is a really big crater. It's almost 6 kilometers deep. So that tells me that something really big probably hit Mars right here and made a really big crater. Could be the reason why we haven't been able to find life. Who knows? I also noticed that this section right here has a pretty big indent, not as deep as this one, but it definitely goes down in a big circle. And then there's a bunch of little ones all the way around it, which was pretty interesting as well. I saw over here a lot of points of really high elevation. So I see a really big flat area that starts to go up really high here. And then I see these three mountain tops. I can tell that they're really high up because they're about 21 kilometers tall, which is going to be really, really tall. I also have this really big one right here by itself. When it forms on its own, not quite as a ridge or a line, that tells me that might be less of a mountain and more of a volcano. And actually, that is Olympus Mons, which is the biggest mountain or volcano in our entire solar system. However, I did highlight one of these in red, and that would be right here. What I see here is a area of lower elevation that goes in kind of a line, almost like a river or a canyon or a channel. So this is what I'm going to be looking at, and this is actually what we're going to focus on a lot. Channels or canyons that look kind of like this on the surface of Mars. And I can see that it's several lines of really low elevation. So when I talk about what a channel is, I'm talking about a long, narrow groove where that forms where water or lava or other liquids must have flown. So if water or lava flows through an area, it's going to go ahead and cause erosion, which is going to take off small pieces of that land and actually wash it away. Last year, when you guys did the water table with Miss Stelling, if you were here in fifth grade, you saw a really good example of how a channel actually forms. So the channel we're going to be looking at on Mars looks like this. And I circled it in red here. We're going to be looking at this channel that actually flows all the way out into this open area here. And if you look really closely, you can see that there's one that comes this way and meets it. And then this comes from here and meets it. You have a lot of small little lines. And then they all flow to a common area. And then it kind of gets flat out here. But you can still see, if you look really closely, these little lines that show that something was still flowing through this channel and being released into this area. So our big question that we're going to be answering throughout chapter 1 is, what caused this channel to form on Mars? Could it have been flowing lava or flowing water? Over the next few days, we're going to try and figure that out ourselves using some of this evidence. So why would we do this? One of our key concepts that we're going to be looking at this year or in this module is that when landforms form on different rocky planets and they look similar, it's evidence that they may have been formed by the same geological process. So what I can do to actually figure out what may have formed this channel is study the same or similar landforms on Earth. If I can get information about how those formed, then I can make a really good prediction or an educated guess about how the ones on Earth, on Mars may have formed. So we're going to be looking at those geological processes. And a geological process is a series of events that causes change in the geosphere. Flowing water and flowing lava are two examples of these. You've probably seen a river carve into the land, like a riverbed. That would be an example of a geological process. Lava could do the same exact thing, and it might look a little bit different, but either way, it's a geological process. We're going to look at some of these compared to each other on Earth between lava and water. And we'll answer a couple questions and make some observations as we go. If you need to reference these slides at any point, I'm going to go ahead and put the entire slideshow on the next slide of your Nearpod so that you can click through them. And if you're in one of my live classes, you shouldn't have gotten to this point because we're going to use those slides to go through them together. So you're going to answer one really quick question now on vocabulary, and then we're going to go ahead and make some comparisons together. All right, we're going to be comparing the geological processes on Earth between water and lava. So here I have two pictures of flowing water and flowing lava. This one is obviously very zoomed in, so we could tell that it was lava, but you can even start to see how it could start to form a little channel as it carves through the same area over and over. Now, Geological processes on Earth that were formed by flowing water. Water covers about 70% of our surface, and it can change the land really drastically. So looking at this example in Botswana, Africa, I can see that the water actually carved a channel into the land, and I have this long, flowing, really wavy, really bendy type of channel that's been carved into this land. So we use these aerial pictures to compare different parts of the earth, and by doing that, we can actually see how something formed. And an aerial picture is going to kind of zoom everything out so that we can get a good comparison of a really large area. You can also have lava that forms these channels from a volcanic eruption. Lava or magma, which is actually melted rock, can flow through an area and actually start to carve into an area. So this is an example of a channel in Hawaii that was formed from flowing lava. And you can actually see how it does a very similar thing that the water did in that it carves into the land, but it does look pretty different. This is a lot straighter, while my water was a lot more windy and bendy. Looking at some other pictures of this geological process from flowing water, some things I notice here is that I have those really long curves and the way the river kind of bends back and forth. In the Amazon, I actually have a channel here that is formed, and then there's a bunch of little tiny ones coming off of the sides that flow into that same river. So that is a sign that flowing water could have formed that channel, and that I have all of these little, what we call tributaries, that go into the same river, and that would cause the channel to be carved out even more. Now, I also have this one in Russia, which is very difficult to tell when you see the next one, because there are some similarities between this and what a lava could do. But you have this flowing river where at one point the land might have been even all the way across. It is now carved into this and very slowly carved out this valley here. Our last one is in South Africa, and you can tell here that it's really deep. So it's been carving into that rock for a very long time. And kind of like over here, it also has some really big curves up at the top, especially right around here. If you follow my mouse, some really big curves there. If we look at how lava flows and how lava forms these channels on Earth, I see quite a few things that actually look similar and quite a few things that look very different. One thing I noticed is that for the most part, if you look at all of these pictures, my path is much straighter. Lava is going to cause less of those curving back and forth than water because it's so much heavier and it's so much thicker. It's going to actually just tend to carve right into the earth in a straighter line. So I can see that when I look at this example in Japan. I can see that when I look at these examples in Hawaii. I don't have as much of that curving back and forth. One thing I also notice in a couple of these, like this one in Japan and this one in Mexico, is that it tends to kind of branch out and make a whole bunch of different smaller little rivers coming off of it or channels coming off of it. So while a channel made out of water might have a lot of little ones leading into it, a channel made out of lava is actually going to have a whole bunch that lead in the same direction. When it gets near the bottom, like in this one in Japan and this one in Hawaii, it starts to actually spread out and pool up in that lava formation there. And eventually that'll cool off and turn into rock and actually start to build up in elevation. So those are some good examples of flowing lava and flowing water, both creating channels on Earth. What our goal is going to be going forward is to use examples of aerial and satellite images to actually study the Earth and then compare it to the channel that we want to look at on Mars, which looks like this, and try and determine if this channel was formed by flowing water or flowing lava. Now, that could be really important to us because if we can determine what it was formed by, it might help us actually understand if life could have been possible in that area. Everything we know needs water, so if we determine that it was created by flowing water, we can go ahead and search for other signs of life. If it was created by flowing lava, that tells us a lot about the geological process of that area, but maybe it wouldn't be the best place to determine life. Or we could start to study how that lava might impact the biosphere that was on Mars in that surrounding area. So what you're going to do next is go ahead and tell me a little bit about the observations you see when it comes to these channels that were formed by flowing water and flowing lava. If you need to look at some differences, you can go through the slides on the next page before you go to your open-ended response and take another look at them before you actually make your comparisons.